Hi, welcome to STAIR Tailored. This is Jessica Mao, and I'm with the University of Texas at Austin. This is part 2 of a 4-part series on how to multiply linear expressions. In this video, we're going to talk about how to multiply positive terms. So like we talked about in the previous video, we want to make sure that students have access to multiple representations. And this can be the CRI framework, which stands for Concrete Representational Abstract or Concrete Pictorial Abstract framework. So students have access to use these representations to understand the mathematical concepts. Now the CRAI model, which stands for Concrete Representational Abstract Integrated, the integrated part suggests that these components are not sequenced in any way or hierarchical, but rather students can use any part of these representation to understand math as they see fit. So whatever type of representation students are comfortable with or confident in using, there's no sequence or the order in which students have to use representations to understand math. Now, multiple representations are especially important for students with mathematics difficulty or disabilities because they provide the students opportunity not only to connect mathematical ideas and concepts, but also provides a variety of ways for them to approach problem solving. In this video, we also want to talk about the idea of vocabulary development. So before students use manipulatives, before they get their hands on them and to start playing with them and explore with them, we want to teach students a set of vocabulary terms relevant to your topic. So in this case, in this series, we're talking about multiplying linear expressions. So we might use terms like variable, constant, linear expression, and quadratic expression. And we want to present these terms with definitions to make sure the students understand the meaning of these vocabulary terms, and as teachers, we consistently use these terms with them as we explain concepts, as we model for them, as we use guided practice, and in our conversation or discussion. One of the popular tools you can use with your students is a FAIR model, in which with them you can find out the textbook definition, student-friendly definition, examples and non-examples of each vocabulary term. Sometimes you can even swap out non-examples with pictorial representations for students to really crystallize that connection. Then, as you transition to using manipulatives and working through the mathematics, you will continue to use these mathematical vocabulary terms with the students. That will not only help students understand the meaning of the terms, but also for them to articulate their own mathematical reasoning more precisely. Now let's turn to the document camera to work with algebra blocks. As for multiplying two variables, we want to clearly and accurately represent what x times x equals. Some students might be tempted to say that x times x equals 2x. If that is the case, you can encourage students to model what that looks like using the corner piece and algebra blocks. As they are using the blocks, you can ask them, does x times x really equal 2x? If students create this representation, this can remind students of two things. First, these blocks here represent the factors of a problem and then establish the boundary for the product. Because these factors are both variables where we don't know the exact value of these terms just yet, the product can be any number. Once again, you're going to point out to students that you're always trying to make sure that the product is in the boundaries of these terms. So if a student says x times x is 2x, then we have a blank space here within the boundary. What do you make of that? I think this is a great opportunity to talk to students about what x times x really mean. It means x times itself. So that really means x times x is x squared. Now let's practice modeling what this expression is going to look like. We're going to use the example of x plus 4 times x plus 2. First, before we start multiplying, we're going to represent the two terms as factors on the side and the top of the corner piece. So if I have x plus 4, that looks like we have 1 bar or 1 x bar and 4 cubes, which represents the 4 constant. So here, this represents x plus 4. So similarly, we're going to do the same thing on the top, where we have x plus 2 with 1 bar and 2 cubes. So here now you see we have the two factors of x plus 4 times x plus 2. And now that we're ready to multiply, this is the opportunity to talk to students about the distributive property, where they might remember that every term from each factor gets multiplied by the terms in the other factor. And this is much easier to see from this representation. First, we're going to start by multiplying x times x, which is x squared that we previously talked about. Then we can multiply x by 2, in which we will get 2x's, or 2x. Next, we can come over here and multiply the x by 4. And we can line them up with 4 x bars. Finally, we can look at 4 times 2. So we're going to grab the cubes to fill in that spot for the product, which is 8. So now that we have the product, we can check with the two rules that we've been using when we multiply with algebra blocks, which is that the factors are forming the boundary of the product and that the product is a rectangle. And before moving on, we want to make sure that while we are representing this with concrete manipulatives, we are also recording them in the abstract form, which are the numerals and symbols. So here's how we can record them. This bar right here represents x squared, so I'm going to write x squared, and all the bars that are x's, we can count them up and combine them, in which we have 1, 2, 3, 4, 5, 6, which represents 6x. Finally, we have 1, 2, 3, 4, 5, 6, 7, 8, 8 cubes, which represents a constant 8. So as we are, again, using the manipulatives, we want to make sure we are pairing them with the abstract form of the mathematics. Like I mentioned previously about CRAI, where I stands for integrated, it doesn't really matter whether students are drawing this pictorially or using concrete manipulatives or in whichever sequence they would like, as long as it makes sense to them and they're comfortable and confident in using it. For instance, if a student decides to skip the manipulatives and move straight to the pictorial representation, that's perfectly fine. The benefit here is that students have a chance to see the mathematics. They can see that the multiplicative relation is modeled clearly and start to make sense of what's really going on underneath the expressions and how to multiply them. Thank you for watching this They're Tailored. Be sure to check out part 3 of this series on how to multiply linear expressions with both positive and negative terms.